Welcome to educational channel of sureshbhattclasses. We are going to learn NCERT class 11 chapter 16 probability. Topic 1 Introduction. Probability is mathematically measurement of uncertainty, and in earlier classes we have learned the definition of probability, which is called the classical theory of probability, in which probability is the ratio of number of favorable outcomes to total number of equally likely outcomes. So we can write probability like this: probability equal to number of favorable outcomes divided by total number of outcomes. Say we have thrown the coin for tossing it, then the outcomes are head denoted by H and tail denoted by T. Then the probability, the total number of outcomes are 2, a head and tail, and the probability for H is 1 upon 2, and probability for tail is also 1 upon 2, because head and tail are equally likely outcomes. The next is the statistical approach of probability, and for this we give the example like this. If we roll a die for several times and the observations are noted, and on the basis of these observations the probability calculated, is the statistical approach towards the probability. And I give the example like this: if the die is thrown, then outcomes are 1, 2, 3, 4, 5 and 6. And say if the die is thrown for 12 times and the outcomes are noted, and which are like this: 1 appears for 3 times, 2 appears for 2 times, 3 appears for 1 time, 4 appears for 2 times, 5 appears for 3 times, and 6 appear for 1 time, and these are the total 12 observations for 12th row of dice. Then the probability for 1 is 3 upon 12, probability for 2 is 2 upon 12, probability of 3 is 1 upon 12, and the probability of 4 is 2 upon 12, probability of 5 is 3 upon 12, probability is 6 is 1 upon 12. So this type of the probability based on the observation results are the statistical probability or statistical approach to the probability. Next is the axiomatic approach of probability, and prior to discussing axiomatic approach of probability, we have to define few terms, and those are like this. The topic second is random experiment. Any experiment is called random experiment if it satisfies two basic conditions. First condition is the outcome should be more than one, or we write that the condition 1 is it has more than one possible outcome, and second condition is outcome cannot be predicted in advance. So if we are throwing a die, then we cannot say what will come. We cannot predict whether 1 will come, or whether 2 will come, or 3 will come, or 5 will come, or 6 will come. Or if we toss a coin, then also we cannot predict whether head will come or tail will come. So such type of experiments, when we cannot predict the things and it has more than one outcome, then such experiments are called random experiments. Topic 2.1 Outcomes and sample space. The set of all the outcomes of random experiment is called sample space of experiment, and each outcome is called sample point. So if we have thrown a die, then the all outcomes when denoted are 1, 2, 3, 4, 5 and 6. So these all are called the sample points, and the sample space denoted by S is the set of all these elements of outcome. So 1, 2, 3, 4, 5, 6 is the set of outcomes of throwing the die, and all these elements when denoted in a set notation S equal to, in set notation 1, 2, 3, 4, 5, 6 is called sample space, and each element is called sample point. 1 is a sample point, 2 is a sample point, 3 is a sample point, 4 is a sample point, 5 is a sample point, or 6 is a sample point. All these elements are sample points. We will learn the sample space by examples. So example 1 is 2 coins, a 1 rupee coin and a 2 rupee coin are tossed once. Find sample space. So our solution for this is 1 rupee coin. 1 rupee coin gives head or tail, and 2 rupee coin gives head and tail. So when 1 rupee coin shows the head and 2 rupee coin also show the head, then we write HH as first outcome. And when 1 rupee coin shows the head and 2 rupee coin shows the tail, then our outcome is denoted by HT. And when 1 rupee coin shows the tail and 2 rupee coin shows the head, then we denote it by TH, tail and head. And when 1 rupee coin shows tail and 2 rupee coin also shows the tail, then our outcome is recorded as TT, which is tail in both the coins. So this all outcome is the sample space, and we write them in the set notation and write like this: sample space S equal to HH, HT, TH, TT. So these all are our sample points, and the total set is the sample space. We go to second example. Find the sample space associated with the experiment of rolling a pair of dice. One is blue and the other is red. Once. Also find the number of elements of this sample space. We have been given two dice, one is blue and other is red, and it is rolled for once. So outcome may be any in any of the die, and if we note the outcomes, then the outcomes will be when blue dice shows 1 and red dice also show 1, then our outcome is 1, 1. When the blue dice shows 1 and red dice show the 2, then our outcome is 1, 2. When blue dice show the 1 and red dice show the outcome 3, then our outcome is 1, 3. Blue dice shows the 1 and red dice shows the 4, then our outcome is 1, 4. Blue die show the 1 and red die show the 5, then our outcome is 1, 5. Blue die show the 1 and red die show the outcome 6, then our outcome is 1, 6. Similarly, the outcome will be blue die show the 2 and red die show the 1, then it will be 2, 1, and we can go like this. So I write all these elements. Those will be 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3 3, 3 4, 3 5, 3 6. That is, the first digit shows the outcome in the blue die and the second digit shows the outcome in the red die. Then 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So these are all our outcomes, and we write in set notation. Then this gives the sample space. This is our sample space, S equal to all these elements, and the number of elements are 36. We go to the third example. In each of the following experiments, specify appropriate sample space. Part 1. A boy has a 1 rupee coin, a 2 rupee coin, and a 5 rupee coin in his pocket. He takes out 2 coins out of his pocket, one after the other. And part 2. A person is noting down the number of accidents along a busy highway during a year. So we solve the first part. We write 1 rupee coin as O, 2 rupee coin as T, and 5 rupee coin as F. So in first place, when he takes out a coin from his pocket, say the 1 rupee coin comes, and in second chance he takes of taking out the coin, then comes 2 rupee coin, so I write T, or a 5 rupee coin may come, so I write F. So here the sample point comes out to be 1 rupee coin O, or 2 rupee coin, 1 rupee coin and 2 rupee coin, and 1 rupee coin and 5 rupee coin. Now if when he takes out the coin, and in first case the 2 rupee coin comes, then the second, when he takes out the second coin, then 1 rupee coin may come, or 5 rupee coin may come. So the sample point comes out to be here is TO or TF. Or when he takes out the coin for the first time, then 5 rupee coin comes, and then second time he takes out the coin, then 1 rupee coin may come or 2 rupee coin may come. So here sample point comes out to be FO or FT. So our sample space in this case will be OT, OF, TO, TF, FO, FT. So this will be our sample space. Now we go to the part 2. A person is noting down the number of accidents along the busy highway during a year. Now we go to part 2. When a person is observing the accidents and he notes down, then there may be 0 accident, there may be 1 accident, there may be 2 accidents, there may be 3 accidents. So the sample space can be written as 0 accident, 1 accident, 2 accident, 3 accidents, and it may be unknown or many such accidents. So we write like this, and this gives us the sample space for the part 2 of the question. We go to fourth example. A coin is tossed. If it shows head, we draw a ball from a bag consisting of 3 blue and 4 white balls. If it shows tail, we throw a die. describe the sample space of this experiment. So we do like this. We toss a coin, then there will be two outcomes. Head denoted by H and tail denoted by T. If head comes, then we have to draw the ball from a bag, and bag contains 3 blue and 4 white balls. We denote it like this. We may draw blue denoted by B, so B1 first ball, or B2 second ball, or B3 third ball, and we may draw white ball, first white ball W1 or W2 or W3 or W4. And if tail comes, then we throw a die, then outcome may be 1 or 2 or 3 or 4 or 5 or 6. So our sample space will be, we make in a set notation, sample S can be HB1, HB2, HB3, HW1, HW2, HW2, HW3, HW4, T1, T2, T3, T4, T5 or T6. So this is our sample space. If we toss a coin, head may come or tail may come. If head comes, we draw a ball from the bag, then B1, B2, B3 or W1, W2, W3, W4, any of the ball may come. And if tail comes, we roll a die, then outcome may be 1, 2, 3 or 4, 3, 4 or 5 or 6. Then our sample space becomes HB1, HB2, HB3, HW1, HW2, HW3, HW4, T1, T2, T3, T4, T5, T6. We go to fifth example. Consider the experiment in which a coin is tossed repeatedly until a head comes up. Describe the sample space. So we go on tossing the coin until the head comes up. So our sample space will be, if in first draw head comes, then we stop throwing the coin. And if tail comes, then we again toss it and it may come head or tail. If head comes, then we stop the game or stop the tossing. And if tail comes, then it will be 2 times tail, and then in third time we may get head or tail. So if head comes, we stop, and if tail comes, then we continue it, and then we throw it for the 4th time, and if head comes, we stop, and this way we will go on tossing the coin till head comes. So our sample space will be like this: H, TH, TTH, TTTH, and so on. So this way our sample space will be, and we stop the tossing the coin until head comes. Here completes this video. Please like, share and subscribe to this channel. Also press bell icon to get the latest notifications.